All right, so today we're going to be discussing compound inequalities. So to really understand this, we need to understand what do we mean by that word compound. A compound is really just a mixture of two different things. So sometimes you'll see it in science, used in science, because you might be mixing two different things together, and as you mix them together, you get some other substance, and that would be some kind of a compound when you're mixing those two things together. What we are going to be mixing together is two different inequalities, and we're going to be combining them into one, or modeling them in one single way. So, what compound inequality represents the phrase all real numbers that are greater than -2 and less than a 6? Now, one of our key words here is and. Now, we're going to be using and or, and both of them are going to be functioning in different ways when we're combining inequalities, when we're making these compounds. All right, so pay attention to when we use and how our graphs look, how our inequalities look, and how are they different when we're using the word or. Keep those in mind as we go through today. So first, I'm going to write it as an inequality. One that I notice right off the bat, so all real numbers, all right, well, I can represent that with an n, that are greater than, all right, so n is greater than, and the first one just says -2. So n is greater than -2. But then we have that and in there. So all real numbers, n, and then we got less than 6. So in this situation, all the real numbers that are less than 6. So we're looking at those two. Now, with and, it is possible to combine these into one. So we got all these real numbers, n, and we've got one situation in which they are less than 6, but we also know that they're going to be greater than a -2. Now that's something you're going to be able to do with and that we will not be able to do with or. But when we do have a situation in which our compound identifier is an and, then we're going to be able to combine them into a single one. Now as we graph this, we've got our nice little number line here. My limits are a 2 and a 6. So a -2 and a 6. So right where I see a -2, I'm going to put a circle. And right where I see a 6, I'm also going to put a circle. I'm going to leave those circles empty right now because we notice that with our inequality symbol, the less than symbols, we do not see that they can be equal to. If I could equal, I would fill it in. But right now, I'm not equal to -2, and I can't be equal to 6. So I'm just leaving it like that. Now, it can be any number that's greater than that -2 and also less than the 6. So anything along the course of that line is a potential solution. So a -1, a 0, a 1, 2, 3, 4, 5, and anything in between, 3.5, 2.6. Anything under that line is a potential solution here. And we can show every single possible solution on that simple number line. All right, let's look at the next problem. What compound inequality represents the phrase all real numbers? All right, so once again, my all real numbers, n, and then we've got that are less than or equal or greater than, all real numbers that are less than 0, making that harder. So all real numbers that are going to be less than 0, so less than, and then we got a 0, so let's go ahead and put that down here. We got all real numbers that are less than 0, or And so or is, once again, that's our key word here. So or greater than or equal to 5. So we once again have our n. In this case, they're going to be greater than or equal to 5. Now, pay close attention to how that translates to our graph down below. Now, this is an or. I can't really combine these. And if you try, you kind of see why it doesn't make too much sense. If I try and put an n in here, then I might say, all right, well, that's less than a 0, but then it's also greater than a 5. But then we get this weird thing going on here where we're saying 5 is less than 0. And it's just not. This is an or situation. It could be this, or it could be this. There are two possibilities that we're working with. All right, now I'm going to start with, right here, we got n is less than 0. I'm going to put my circle above the 0. It says n is less than, so I'm going to select all the numbers that could be less than 0. So starting from 0, all these numbers are less than, and it keeps on going for forever. All right, those are just all the numbers less than 0. Once again, my circle was empty because I can't equal the 0. However, in n is greater than or equal to 5, put my circle above that, I am going to fill it in because, yes, I can equal a 5. 5 is a solution here. And n is any number that is greater than that. So you'll notice a difference here. With the and, we had the lines converging in on one another, and it had to be stuck between those two. All right, it had to be between a -2 and a 6. If it was an 8, then it didn't match up because it wasn't less than a 6, so it wasn't a solution. Both of our statements, both of our inequalities had to be true at the same time, or it didn't match. With an or, either one could be true, okay? So long as we're less than a 0, sure, that's a solution. Or if you found a number greater than a 5, yeah, that's also going to be a solution, all right? And so we also see these two lines that are diverging, that are pointing out in different directions. And we're going to see that a lot when you're working with or statements. Now, what are the possible solutions of -3 is less than or equal to m minus 4, which is less than a -1? Now, we're just solving an equation, or solving an inequality, I mean, and similar to what we've done before, we're just going to treat those symbols like an equals, but we haven't really seen any situations in which we had two different equals signs before. Keep in mind that just like when we do an equation, I'm always saying, do it to both sides. Add the 3 to both sides. Divide by 4 on both sides. We've got more than 2 sides. We've actually got 3 sides now. The side that we're going to focus on, though, is the one with the variable. All right, so right there in the middle. There's my variable. I want to get my variable alone. If I can do that, then I have successfully solved it. So I'm ignoring that -3, I'm ignoring the -1, and I'm only focusing in on that -4, because that -4 is in the same place as my variable. So do the opposite, so plus a 4. Now, I'm doing it in the middle. In order to keep everything balanced, have to do it on the left. I also have to do it on the right. So in these compounds, we got compounds because we've got the two different inequalities. They're put into a single statement. You need to make sure you're doing it in all the sections. So we had 3 sections. So we get 1, same symbol still, -4 and +4 is 0, m minus 0, it's just an m. Bring down the same symbol, and 3. So m is between a 1 and a 3. I'm going to draw my dots now. So dot above, or a circle above the 1, circle above the 3. I can equal the 1, so I'm going to fill that in. I'm not filling in the 3 because I can't be equal to the 3, and just a line in between. So M would be any number that falls along that number line. All right, so now we're going to talk about grades and how grades are calculated. Now, your grade is calculated based on a mean. And many times people refer to this as an average. An average can mean different ways of finding that central tendency. But for right now, just know that when we say average, we're talking about the mean specifically. The way we do that is to add up all the scores. So we would have the sum of the scores divided by the number of scores. All right, and this is how Gradebook is calculating your grade. It is taking all of your scores divided by the number of the scores, and that gives it a percentage that it can work with. Now, in this problem, we're going to be dealing with that particular calculation in order to identify how to get a grade that this student wants. So, to earn a B in your algebra course, you must achieve an unrounded test average between an 84 and, notice that word and, 86 inclusive. Inclusive is saying that it is included. So inclusive is like saying, yes, we can equal that. That's what that inclusive is getting to. If it was exclusive, no, we wouldn't be able to equal it. All right, now, your scores, you did an 86, an 85, and an 80 on the first 3 tests of the grading period. So those are your scores that are already in Gradebook. You want to know what possible scores can you earn on the 4th test and get a B. So you're aiming for a B. So we want to know what are those possible scores to get on the 4th and final test. Okay, so in order to do this, first, I'm going to write this as an inequality. Now, we already know how to calculate an average. An average is adding up all the scores. Well, we have scores. We have 86 plus an 85 plus an 80. And then the 4th score we don't know, so we're going to put it in as a variable. There's my x. And then we divide it by the number of scores. Well, there were 4 tests, so divide it by a 4. Next, we know where this has to be between. This has to be between 84 on the low end and 86 on the high end. So whatever score we get is going to have to be greater than that, but smaller than that. Next, we saw inclusive, so or equals to, or equals to. All right, now, just like before, we've got our 2 inequality statements. I'm going to draw this line straight down so that we're super clear on where our sides are. Remember, whatever we do in one side, we're going to do to all of them. Now, I'm going to start off by, I notice I've got a fraction in here. And let's just go ahead and do some fraction busting right to begin with. If I multiply this entire side by a 4, then I'll have 4 over 4. 4 over 4 is 1. All right, so just all that multiplied by 1, that makes it nice and easy. If I multiply this by 4, and multiply that by 4. So I've now multiplied every section by a 4. Okay, 84 times 4, we're going to get 320 plus a 16, so 336. be nice on me if I'm calculating this wrong. I'm doing it in my head on the fly. So 4 times an 86, so 320 plus a 24, so 344. Now, in the middle, because we had that 4 over 4 situation, we're just left with our 86 plus 85 plus 80 plus x. Bring down the same symbols. All right, so now 86 plus, we're just going to simplify for this next step. I've got a bunch of numbers that I can add together. An 86 plus an 85 is going to be 160, 171, 171 plus another 80, 251. So we got 251 plus x. And just bring everything else down. All we did was add what was there. All right, so now I've got my variable there in the center. All I really care about is getting my variable alone. There's only one thing with it, and it's a positive 251. We're adding that 251, so I'm going to do the opposite. Not to one side, not to two sides, but to all 3 sides. Okay, so we're subtracting that 251. So in the middle there, that leaves us with a 0 plus x. So we're just going to have x. 336. So we're going to get a 5. Get an 85. And then over here, 344 minus 251. And a 93. So, what can I score on the test and still get a B? Well, I'm going to have to score somewhere in between 85 and a 93% on that test so that we can still get a B on that test. Or so that we can still get a B in the class overall. All right, so once again, we're solving. This time, rather than an and, we're dealing with or. I'm going to treat this as 2 completely separate problems as I solve this. Now, the and, you noticed we solved it largely as one problem that had 3 sections. This is going to be 2 different problems. Each problem is going to have 2 sections in it. All right, now remember, first thing we want to do is focus in on where that variable is. We want to get the variable alone. We're focused in on the numbers that are on the same side as that variable. So, with this first problem, I've got a 3 and a 2 that are on the same side. Let's start with that plus 2. So, to eliminate that, I'll minus 2 from both sides. 2 minus 2 is 0. 3t plus a 0 is just 3t. Bring down the same symbol. Negative 7 minus 2 will be a negative 9. Now I deal with that 3. We were multiplying by a 3, so now I'm going to divide by 3 on both sides. 3 divided by 3 is a 1. 1 times t is just t. Negative 9 divided by 3 is going to be 3. So we got a t is less than 3 for our first one. And now to our other or statement. Now we've got a negative 4 and a positive 5 over here. Now let's start with what we're adding. So we're adding a 5. I'm going to subtract a 5 from both sides. That means our 5 minus 5 is a 0. Negative 4t plus a 0 is just negative 4t. 1 minus 5 is going to be negative 4. We're going to have to be careful here because we are dividing by a negative. Anytime you divide by a negative number, it means we're going to need to flip the inequality. All right, so you'll notice I changed its places. Now, a negative 4 divided by a negative 4 is just 1. 1 times t is t. Same thing on the other side. That just became 1. And we're just left with t is greater than 1. So there's our two inequalities. T is less than 3 or t is greater than 1. So to graph it, first we go down here. We've got, there's our 3. T is less than the 3. Okay, or t is greater than 1. And so essentially we just found a situation in which basically any number works, because we've just, oh, I made a mistake. Hopefully someone saw it. Give yourself a pat on the back if you did see it. Negative 3. All right, so negative 9 divided by 3 should have given us a negative 3, meaning that my circle was supposed to be down here, and any number less than that negative 3 or t greater than the 1. That makes a lot more sense. So yeah, it's not just any number. We do have a few numbers that would not qualify in this, but there's our graph. All right, to end this up, we're going to talk about interval notation. Interval notation is just another way of writing these problems. Now, when we're using these square brackets that you see in red, the square bracket means that we are equal. We can equal it. All right, this is like greater than or equal to, less than or equal to, situations like that. Okay, they're in green when we're using the rounded brackets, more often called parentheses. It means we do not equal it. We can't equal it. Those are just less than or greater than situations. So we're going to graph and write an inequality for negative 4 to 6. So I'm going to go ahead and start with that graph. Let's see, it says it starts at a negative 4. That's the first number. I'll draw my circle there. I do notice we used square bracket, so we can equal it. So I'm also going to fill it in. Okay, next we go up to the 6. All right, dot there. It had the parentheses. It's going to remain empty because we're not actually going to be able to equal the 6. Now this one is going from negative 4 to 6, and that's what it's saying. So to write that as an inequality, well, we've got our x. We see that it's bigger than or equal to the negative 4, but it also had to be less than 6. Okay, now for this next one, we do see an or situation. Remember how those graphs will look a little bit different. Now this one wants us to graph it and then put it in interval notation. All right, so x is less than the negative 1. So let's start, or positive 1, I mean. So we got our dot above the positive 1. Any number that is less than it, so it's just going off in that direction. We can equal it. We see that's less than or equal to, so I'm going to fill this dot in. Okay, and now my next one, or x is greater than the 2. So starting at the 2, going greater than, we're not filling in that dot because we can't equal the 2. We don't see an or equals there. But there's my graph. Now, in order to write in interval notation, we start with the smallest possible value. Well, -1 is pretty small, but -2 would be smaller, and -3 is smaller, and -4 is smaller, and -5 is smaller. And this red line for x kept on going and going and going, and it's never going to stop. So what is the lowest possible number this ever can be? Well, -infinity. All right, that's going to keep on going in the negative direction for forever. Notice I also used a parentheses there because we're not going to be able to equal infinity. Infinity isn't a number. We can't equal it. So by default, if we're using infinity, we're also going to have those parentheses there. Okay, and that went starting from -infinity, going all the way up, 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 and then it had to stop at a 1. So I put my 1 there. I could equal that 1, so I'm going to use my square bracket. So that first section went from -infinity to a 1. This next section starts at the 2. We can't equal the 2, so we use the parentheses in there. And how high did it go? We're now just kind of following. How high is it going? How high is it going? How high is it going? It's never going to stop. This time it's going in the positive direction. So it's 2 going to positive infinity. I can't equal infinity, and so rounded bracket. Okay, this is how to do compound inequalities with graphing and interval notation. Work on your assignment and do your best.